Welcome to the Safety in Numbers podcast. I'm your hostess, Sheila Hanson. This is episode 17. In this episode, we will explore the importance of memorization of math facts. And by math facts, I simply mean like single-digit calculations, addition and multiplication and their inverses. So something like 6 plus 8 is 14 and 14 minus 6 is 8. Or 6 times 8 is 48 and 48 divided by 6 is 8. Those are math facts. But also the understanding of how those facts change with place values that are larger than 1. For instance, 60 plus 80 is 140, and 60 times 8 is 480, or 60 times 80 is 4,800. Over my years of teaching, I've heard all sorts of different theories behind whether or not you should memorize your basic facts. Most of it is geared towards not memorizing it, especially when I was in my early years of teaching, which was in the early 2000s. And what I discovered over my experiences is that it is actually the best tool that you can give any math student for these reasons. When a person knows their math facts fluently, the chances of error in some basic calculation is greatly decreased. Now, everybody's going to have those, brain fart moments where you say that 2 times 3 is 5 or 2 plus 3 is 6. But those incidents are greatly reduced when you have your math facts fluent. If you have your math facts memorized, it quickens the problem-solving process. Because when your math facts have to be recalculated every time you use them, it increases the mental strain when you're doing multi-step problems because you add to the complexity of the problem. And that leads to mental fatigue and discouragement. So if I have to figure out that 7 times 3 is 21 by going 3, 6, 9, 12, and doing this every single time I have to do it, I'm increasing the time it takes for me to do that calculation. And so it's almost like you're increasing the time of your jog. And if you're not very strong at it, that causes mental fatigue. And so then kids see word problems or multi-step problems and they just give up because they know it's going to be hard because they don't have those facts memorized. They may not realize it's because they don't have their math facts memorized, but they don't. They have to spend more time on the problem than it really should. And they might see kids that have math facts memorized, like zipping through those problems right away, and they don't understand. They think that they're just dumb. They just don't get math. I just don't get math. My parents don't get math. My whole family just hates math. I hear that. I used to hear that a lot when I taught. But it's honestly as simple as adding some tools to the tool belt. Math facts. Memorizing math facts helps to teach pattern recognition because they hear those facts in their heads and they become familiar with them or they see them a lot. And the more familiar they get with them, the more pronounced the patterns become in those numbers. And when they start recognizing patterns in those numbers, especially like skip counting sequences and writing math facts on the multiplication chart, when they start seeing those patterns, they start connecting it to different things. And then all of a sudden, pattern recognition becomes very, very easy for them, or at least a lot easier for them. And when you say, hey, what do these two numbers have in common? Then they can go much further, much deeper than the surface of just what the number looks like. The idea of fingertip facts allowing students to think deeper and about more complex topics came from when I was having a conversation with an educational psychologist many years ago. And they said that the fingertip facts and memorized facts are what gives a student the tools to go deeper and make whenever all the little jobs in a process become easy and fast, then you have the time and the mental capacity to think much, much deeper about a process. And this is true for anything, whether it's like reading. If you don't know your letters and your sounds when you're reading very well, then actually the act of reading becomes very difficult. If you have a lot of sight words learned and you know all of your sounds and how to pronounce words, then it becomes much less mentally taxing. And those fingertip facts are the basic tools for math, along with a basic understanding of counting. And people think, oh, well, counting, that's so easy. If you check out one of my connections video, I believe it's connections video 1, it explains how counting is much, much more important that you practice and that you teach deliberately to a student than you might realize. So check out that video. But I would also explain this to my students in this way. And yes, I would explain educational psychology to my students. They need to understand why I'm doing what I'm doing, because you always get that, do we got to? Why do we have to do this? So I always had an explanation at a ready. I always had a reason for doing the things that I did. And I would explain it to them like this. So, my brother is a plumber. Somebody calls him up and says, yo, Sam, I need you to build me another bathroom on my house. So he comes over to the house and he says, hey, where do you want me to build this bathroom? And I point over there. And he looks and he goes, you know what? I'm going to need a tape measure. I'll be right back. And he goes out to his truck, gets in his truck, drives to his house, goes to his workshop, gets his tape measure, gets back in his truck, drives back out here, and then goes out and starts measuring. Well, and then he takes the measuring and he's like, wait a second, I'm going to need to write this down. I'll be right back. And he gets back in his truck, he drives back to his shop, he gets some paper and some pencil, and he drives back. And then he's like, you know what? I'm going to need to dig a hole so that I can attach to the sewer line or whatever he has to do. And so he's like, okay, I'm going to need a shovel. And so he gets in his truck and he drives to his workshop, he gets a shovel and he drives back. That's the same amount of extra mental work that a student is doing when they cannot add 5 and 7 like that. And if they have to go 7, 8, 9, 10, 11, 12, it's like they have to go out to their truck to get a tool every single time they do something. So by helping the student memorize their facts, you're making their further study of math so much easier. And when you allow them to go on without having facts memorized, you're setting them up to have a much more difficult time. That's the way I see it. I have seen so much success when I worked with students who, when I would do it at school with the multiplication chart and timing the multiplication chart. When I work with tutoring students, one of the first things I assess is, do they have their addition facts memorized? And if they don't, or if they do, or if they don't, then I check their multiplication facts. If they don't have either one of those memorized, then that's the first thing I do, is we start looking at single-digit addition. We start looking at numbers from 1 to 5, and then we add the numbers from 1 to 9, and then we start looking at 10, and then we start looking at adding the same number over and over and over again, and I go through that whole process that they've done, but they've done it so lightly or so surface that they never built a framework in their mind for it. So that's what I learned from the educational psychology department and world, and I checked out, or I bought a few books on that topic and learned quite a bit more. So even though the thought of memorizing your basic facts is not real glamorous, and like I said, in the early 2000s, it was almost like, oh, you're spending time memorizing facts. That's so last century. But if you're a higher education teacher, such as 7th, 8th, 9th, high school, and you get a kid in front of you who cannot do multiplication, and you say, hey, you're going to need to start simplifying your fractions when you do your work. And they're like, well, how do you do that? And, like, oh, this fraction is 12 over 24. What is that actually equal to? I don't know. This is an actual conversation I had with a student. I was so shocked. This is one of the conversations that made me start doing the multiplication timing. And I looked at them and I said, well, what do 12 and 24 have in common? And they were like, Well, they both have a 2, and I thought they meant that they were both divisible by 2. So I said, yeah, that's right. They're like, but the number on the bottom, the 2 is first. And then the number on top, the 2 is second. And I went, we got to do some multiplication work here. So while understanding concepts is important, it doesn't guarantee that they will remember anything. Second of all, I want you to understand that calculators are a tool also, but they have a very different purpose. Not to do things like 3 times 7. The purpose of a calculator is to make large, time-consuming computations more manageable. Things that have like large numbers or complex complications like square roots or sine and cosine and tangent or complex long division problems. That's what calculators are for. So how do you get kids to memorize their facts? Well, you don't. What I mean by that is most kids are not going to naturally memorize their facts, and you honestly can't make them do something. They have to choose to. So what I would do is structure it into my classroom. It was a part of our assignments. So we would do different activities that are designed to help them memorize. And how do you memorize something? Well, the number one most effective memory tool is repetition. Our brains are designed to remember when something is repeated. Think about how good you are at it when something is repeated. Think about commercials. They repeat those over and over and over again, and most of them we could probably say by heart. Understanding the concept behind what you're learning is essential for the initial understanding and the initial explanation, but it does not guarantee memory. So for a repetition, just take once a week out of your classroom and do something that just reinforces their basic facts. Things like addition. You can add the same number to a random number or play addition games. Subtraction, the reverse of addition. So start high and randomly or subtract the same number every time. They should see patterns, especially with 5s. There's a very strong pattern. Multiplication, explore repeatedly adding the same number over and over and over again. And then do the multiplication timing I've described in my concept video of memorizing multiplication, which I'll link at the end of this video. But do the timing with the promise that once they reach the goal consistently, I always said that they had to reach the goal at least 3 times in a row in order to not do it again. And that can be a very strong incentive. And then there are all sorts of multiplication games. I would have a fun Friday, and we would do some form of a math game on Friday just to break the monotony of writing notes, me explaining, them having to do homework and grading homework. It gets monotonous. So on Fridays, we would do something different, and it always involved some sort of a game. I encourage you to make a competition out of this practice of memory. It adds what I call positive pressure to a student. They don't necessarily have to be competing against everybody. It doesn't have to be a big, huge, obnoxious celebration. They can just be competing against their past self. That was the main one I would encourage my students to do. I'm like, look at the timing you did last week. I encourage you to try and beat that this week. And then after we would time, I'd be like, okay, who beat their own time? Good, excellent. Sometimes you will, sometimes you won't. So I'd let them know that too. Like everybody has off days occasionally, and that's all right. So you did great last week, and this week something happened. You just couldn't figure out your 4s, and it just got off track. And I'm like, you know what? Those days happen. You'll do better next time. Occasionally they would compete against peers. Some kids are not real motivated by doing that. Other kids are extremely motivated by doing that. I had this back and forth going on between who got the fastest time between these 2 kids, and they would time, oh my goodness, they would get so into it, but they were friendly about it. And then also they could compete against me, which honestly, my fastest multiplication timing of the multiplication table was 2 minutes and 14 seconds. And I couldn't do that very often. I usually got about 2:45. And so when they could beat me, they thought that was pretty awesome. And that was very much a self-confidence booster and a motivator for them. Make your classroom a place where they don't automatically get to reach for calculators for everything. So I didn't allow calculators unless they were really needed. In fact, the first 2 or 3 chapters that we would do, or units that we would do, they had to complete the test without a calculator, because it was all about integers and learning to calculate with integers, and fractions and learning to calculate with fractions. And so I wanted them to be able to do those skills by hand or from memory. It allows a student to build that framework for using their calculation skills when they need to, and not always picking up that calculator for simple things like -3 + 5. They need to understand that framework and have the concept built into their mind and memorized well enough so that that's not something that they need to do. This includes calculating with fractions and decimals, and even squaring numbers up to 225. So create situations where they must do mental math. I would do like mental math word problems. So just a situation problem, and let them calculate it in their head. Tell them, you don't have to write your work down, but you do have to get the correct answer. And they could not use a calculator. Then we would do class competitions of mental calculations, and that got really fun, especially when we learned distributive property. And so you could distribute, like they would get to where they could do like 3 × 745 in their head, and that was such a powerful skill for them, and it made them feel so powerful because they're doing a large multiplication without a calculator and without even paper and pencil. It's a great esteem booster. I would always tell my students, I'm like, I know that this practicing stuff gets boring. And you know what I like to do? I like to play games. So I would make up games or look up games on the internet to practice. And if you look at the history of games, they're actually a way of practicing skills in a safe area, in a safe zone. So like chess is a way of practicing warfare and strategy, but in a safe area where nobody actually gets killed. And if you watch the animal kingdom, kittens and puppies will play fight. Well, why do you suppose they do that? For entertainment? No, it's because as adults in the wild, they're going to need to have those skills. So they practice them by playing. So if you know that students are going to need to have skills of calculating quickly and accurately, then you build a way for them to develop that skill into your class, because that's part of what you're teaching. And I know a lot of people don't like competitions in games because there's always somebody that loses. And yeah, that's a part of it. Loss has to be a part of the game because you learn more from your losses than you do from your wins. So you teach the kids to celebrate the wins of the students even when it's not them. Celebrate so-and-so's win because they did really well, and celebrate with them. But also teach them how to learn from their losses by asking them, well, what will you do differently next time? Or what do you think went wrong? And have them analyze that, and learning to ask themselves those questions and sort of reflect on their own work teaches them to do that naturally, and then they start doing that on their own. 2 things result in this. Number 1, kids learn that a loss in life does not mean the end of the world. And they also learn that winning isn't everything. And you will more often learn from your losses and your defeats and your mistakes than you ever will from your wins. The more a game is played, the more a player learns how to strategize. Strategizing is a way of thinking ahead, planning and anticipating consequences, and dealing with those consequences and how to recover from those consequences. All very important skills to have. The kids will complain about having to practice their multiplication facts or their addition facts. That's okay. Kids are supposed to complain. That kind of makes you double check why you're doing what you're doing and make sure you are on the right track. If you ever cave to student complaints, then you teach your kids that they should never have to be uncomfortable or do anything difficult. And that's not a skill. They're going to need to learn how to be in uncomfortable situations and do difficult things. So I would rather them learn those skills in a safe classroom rather than get out into the real world when they're trying to support themselves and figure out that, hey, there's part of this job that I don't like and it's very uncomfortable because it's hard. And that's a part of it. Talk to students about practice with compassion and understanding. Say, yeah, I understand this is hard, and that's okay. But explain that it's often necessary to do things that are difficult, and it's good to be able to suffer through that. Because if you learn how to suffer through those difficult things, they become not so difficult, and you start being able to prioritize your life to do, you know what, I'm going to do that difficult thing right now so I can do the fun thing later. Opportunity cost. The kids don't always like it, but the purpose of a teacher is to prepare your students for what's coming next and to push them toward growth. That growth is often uncomfortable, but when you get to that next stage and you look back, you're like, oh man, that growth was absolutely necessary. I'm so glad that I did it now. There's so many things that I am so glad that I did, but they were really, really hard at the time. And I found in the long run that my kids really respected the fact that I knew what I was doing. I had a belief system and I stuck to it. I didn't cave. You know, there were a few times I would cave if I wanted my students really to do something. I would cave into their complaints and say, all right, we'll take a break now. Because we all know that you have those days. That's why at the beginning of the year, everybody would get a homework pass. And I would tell them, I'm like, if I were you, I would save this for that one day when you're just, and you can't figure it out, or you can't make yourself sit down and do it, or there's some family emergency and you don't get to it. Save this pass for that time. And there are some kids that would save it. I'd had kids that saved their homework passes all the way till the end of the year, and then I told them they could turn them in and I'd give them extra credit. And then there's some kids that it's just like cash burning a hole in their pocket, and they would use it that very next day. And then they would run into the fact that, oh man, I don't want to do this homework. And I'd be like, well, do you have a homework pass? No, I used it last week. Can I have it back? I'll do that assignment. Sorry. No, I don't keep homework passes. Once you turn them in, I tear them up, and then I put the grade in as exempt. So I can't give you that homework pass back. I'm really sorry. I hope you get to earn another one. And I am. I do. I hope they do get to earn another one. And I hope that they are able to take a break once in a while, but earn that break. And the way they would earn homework passes in my class, the main way was to get an A or a B on a test. This video was a lot, and I know it's going to be much longer than I even wanted to make it. But it's extremely important to understand why the memory part of class and of learning is essential. Thanks for watching. See you in class.